Assalamu alaikum everyone. Welcome you again to the part 2 of the Webots environment setup in the physics interaction. In the part 2, we will look into friction. I am Mohammad Mujur Samrahi, welcoming you all again. In this part, we will look into how different objects react to friction. So to start that, we will use the same four objects that we have previously seen. We will also add the Pioneer robot that we have Pioneer bot that we have seen before. Right? So we have seen the bot, I think, in the collision video. We will like to bring that back to demonstrate a bit of how bots can behave in friction. So we will use the Pioneer 3DX. All right, here we go. Right, let's see if it's blocking any view or not. Yeah, it's straight there. All right. So these are my objects, right? I have already applied physics to almost all the objects. This cone has been applied physics, and this cone is very light with a mass of only 1 kg. The cylinder has been also applied physics, and the cylinder has a mass of 10 kg, I think 100 kg. So this is quite heavy. This wheel, on the other hand, has not been applied any sort of physics. This is to demonstrate as a control. So we'd like to see how what will happen if physics is not applied to like and like how an object that has been not applied physics will react to friction. Uh, the bot will have sensors and will move forward. And so yeah, physics obviously has been applied to this bot. And this sphere in this sphere also we have applied physics. Just move this a bit. All right. So I think there's enough space between them. All right. So now let's start applying. How can we apply friction to the surface? For that, go to your world info and to contact properties. Double click on that or add a node. So you will see contact properties. Add that. Yeah. So once you're done adding contact properties, you will see contact properties has been added. And if you go into that tab, you will see there are multiple like sub columns. But for this video, we'll look into friction, right? So that will be column friction. So here you see the default friction is set to 1. 0 means there's no friction. And if you set it to -1, it's like negative friction. So it will start moving in the opposite direction. All right. So we would like to incline this surface because this till now this plate has been like it's straight or linear in that regard. So there will be no movement right now. But if we incline this, we will see friction will play an important part, right? Because if inclining this, weight does play a part, and then it causes acceleration. So friction will play a part. And we would like to see what will happen when if there is friction and how that will tackle it. So in that way, initially we will set the friction to 1 and see how these different objects react to friction. So make sure your simulation is off, because if you turn on the simulation, all of these objects will just fall down instantly. So make sure they're off, and then let's rotate it a bit. We will rotate it slightly. Make sure your objects are higher so that they're not like between the surface. If that's the case, they will just like fall down. Okay, let's see how they behave with friction. Now my friction has been set to 1. I think we should save this because just in case. Yep, my friction has been set to 1, gravity to 9.81, and let's see how this behaves. Yep. Okay, let's go. You see my this is a heavy object, it did not fall down, and my bot could go through because of this incline. There was enough friction for him to for the object to roll through, and it fell down in this direction. whereas the other two objects, they could not hold on to themselves and they fell down. So let's go back and okay, let's go back and change the friction a bit. Let's lower the friction to 0.5 maybe. Now let's see what happens, and let's put it here because you know there's enough motion to go through. Okay, let's now you see the ball could not hold himself and itself, and it went down because there wasn't enough friction to grip, and like it could not move. If we run the same thing, let's say with friction as 0.7 this time, let's see how it behaves. You see, still the object could move. Now let's say we want to make sure this objects fall down. Let's decrease the friction. Still nothing. Nothing. Maybe if we change the rotation a bit. See, there's not enough friction. I think this object is quite heavy. Um, we friction, you see this object rolls down as there is not enough friction to hold it to. On the other hand, this object has not moved an inch because there has been physics has not been applied and has remained in that still in that position because it does not follow the rules of physics. So this is a demonstration of how you can see friction can play a part. You can just mingle with different friction and see how it can change. So yeah, and friction will determine whether an object can stick to the ground or climb or move at different velocities and whatnot. So like you can change the friction to your certain requirements as well. So thank you everyone. Hopefully you have understood from these two videos how physics is very important for any sort of interactions, collisions, and to mimic real life issues, physics needs to be implied. So thank you everyone. Have a nice day.